This brief tutorial will show you how to use EDGECAM's parallel lace cycle to rough out the uppermost of this solid model component. To create the perfect toolpath, I'll also need to create extra CAD geometry. I've created the parallel lace cycle and now I'm required to pick the target CAD geometry. In this case, I'll naturally pick the whole of the solid body. And as instructed, the toolpath flows over the model. But look at the depths of cut, they're too deep. And also observe how the tool dives into the deep pocketed areas. This wouldn't be suitable. So let's try exchanging the original CAD geometry and we'll pick the top face. After all, this is the area that we wish to machine. We'll go and simulate it using Rapid Result. Rapid Result's a good idea when you've got long toolpaths, but still it's no better, it's probably worse. What we need to see is the tool smoothly and gently undulating over the upper face, but that's the problem, we don't have individually the upper face. The optimum solution is to modify the model inside our designer. The replace face and remove face commands are perfect for this application. Simply pick and select the faces to be removed, and once modified we would then return the model back to EDGECAM. Maybe you don't have access to a modelling system. Thus you need an alternative, and EDGECAM can do this using surfaces. I'll first of all create a layer, and then from the feature tab I'm going to create geometry, specifically a surface, and I'll pick the top face. And what EDGECAM will do is it will create a trimmed surface of the exact same image as the top face. Now this trimmed surface on itself is no good to us. We want an open surface, so what we can further do is we can explode the trimmed surface. We select the trimmed surface and it explodes it into a B-spline surface, and this is actually the shape that we wish to machine. So this resultant surface is now offered to our parallel lace cycle. We simply repick the new entity, which is our B-spline surface. And now if we check the toolpath, it will gently undulate up and over the shape, and this is replicated on the solid model inside our simulator. It's not quite perfect though, because we can see that we've still got stock left at the side of the part. So we can't change the toolpath, but we can certainly change the CAD geometry. In other words, we can stretch the B-spline surface, and we use this by using the extend command, again found in the surfaces menu. We place a factor and then we select the edge of the B-spline surface, and we do the same to the opposite side of the B-spline surface. You can see how it's clearly stretched, and now we regenerate the toolpath, and of course CAM must follow CAD, so therefore we're now seeing the perfect toolpath. Hope you've enjoyed this tutorial. Thank you for watching. To this exercise, where I'll be using EDGECAM's advanced 5-axis cycle to machine the two side fillets seen on this model. In doing so, I'll also need to create extra CAD geometry to produce the optimum toolpaths. I'm going to be using parallel cut strategy inside our 5-axis cycle, along with a small amount of tilt and a small amount of step over. Within the link parameters, I'm keeping the tool close to the part with the Z level at 50. The important pick here is the drive surface. The drive surface is the course of direct pick to the solid model, and this is actually causing an issue. Firstly, the fillet face is 180 degrees, thus the tool is obliged to run all the way along this shape, forcing the tool to collide with the vise. And secondly, the ends of the fillet is naturally uneven, thus the toolpath mimics this shape, making the start and end positions uneven. So in this instance I can't actually change the model, but what I can do is I can create some more geometry that helps me. So in this case I'm using from the feature tab, geometry from solid. I'm creating a surface of the face of the solid body, working with layers to make life a little bit easier for me to see. And what I can do is we've created a trimmed surface. Now we can explode the trim surface, and this naturally opens the trim surface into a B-spline surface, which gives me the perfect shape. It's opened out into its natural shape. Now what I can simply do is I can re-inform my advanced 5-axis cycle to forget the face feature that I first of all selected and replace this with the B-spline surface. This now gives me the perfect shape. The toolpath begins and ends in exactly the right position. My second problem was that due to the shape of the surface, the toolpath will go all the way around this fillet, thus crashing the tool into the vise. So what I'm going to do is I'm going to make a boundary to clip the toolpath. I'm going to create a layer just so I can see things a little bit more easily. And this particular piece of geometry that I'm creating wants to be in the correct work plane at the correct level. So I just pick the model in order to get the level. And then I'm going to go to the geometry menu and select a rectangle. Very crudely, I'm just going to create this rectangle. As long as the baseline is in line with the edge of the part, then this will be okay. In the cycle, I'm going to activate 2D containment, making sure that I'm projecting in the X direction. And then of course, I'll be asked to pick the boundary, which in our case is this crude rectangle, and it clips back the toolpath perfectly. Now that tool won't crash into the vise. And just to make doubly sure, I'll check this in the simulator. So boundaries are a great way to clip back the toolpath, but here's an alternative method. First of all, I'm just going to make sure that my work plane and my level are correct. And what I'm simply doing is drawing a single line that starts at one side of the model and completes at the other side of the model. And what this line is going to do is to help me draw a ruled surface. So here's the line. Rules of a ruled surface say you need two entities, so my second entity is going to be created by offsetting the line. Thus now I have two entities, two lines. And now I can go for the ruled surface, and we need to pick the two lines on the same side. And now if we just render, we can see this ruled surface. So using the drag and drop method, I'll copy the original 5-axis cycle. I'll edit this cycle, deselecting 2D containment. And for my drive surface, I'll deselect the original surface on the opposite side and now go for the fillet on the new side. But here is the catalyst. We're going to use gouge protection. The flat surface, our ruled surface, will act as a block, or what we call a check surface. As soon as it hits the check surface, it will stop the toolpath calculation. So we pick the ruled surface, and now what you'll see is that as soon as the tool touches the ruled surface, it will remove its toolpath. Could argue that probably needs to go a little bit lower, so no problem. We'll just translate the two lines and the surface further down. Just use the layer to isolate what we need to see. We'll pick those surfaces, everything will move down, and in a time-honored way we'll now simulate and regenerate the toolpath. Now, because the check surface is further down, the toolpath is allowed to move further down. And we'll check all that once more inside the machine simulator. Remember, what we were wishing to obtain was not to collide the tool against the vice jaw. This looked good. Thanks for joining me on today's tutorial.